Question 6. The stem and leaf diagram gives the blood pressure X for a random sample of 19 female patients. And the key would be that 10, line 1 means a blood pressure of 101. A says, find the median and the quartiles for these data. Now, there are 19 pieces of data, a random sample of 19 female patients. So, when we go to find Q2, when you want to find the middle of that, you can take 19 plus 1 and divide it by 2, and that will tell you the value that you're looking for. So this will be the 10th value. Now that makes sense, because if you come to the 10th value, there will be 9 pieces of data, 5, 6, 7, 8, 9, then you will get to the median piece, then there will be another 9 on that side, and that would be your 19 pieces of data altogether. So when I look for the 10th value, there's 7 pieces of data up to here, so there's the 8th, 9th, 10th piece, which is 122. And in the mark scheme, this is a site of mark for 122. Now for the lower quartile, you're now looking for halfway through these 9, which will be here. So there are various ways you can do it, but probably the simplest way is to take 19 plus 1, divide it by 4 now, because you're finding a quartile rather than halfway through. And this gives you 20 divided by 4, as in the 5th value. And there's 2 here, 3rd, 4th, 5th piece of data is 117. For Q3, the upper quartile, you want to come 3/4 of the way through. So after dividing by 4 to get a quarter, you need to multiply by 3. And so it's not the 5th value, but the 15th value. And you can see that's true, because that's the 10th value there, 11th, 12th, 13th, 14th, 15th value. And now you've got 4 pieces of data, 4 pieces of data, 4 pieces of data, 4 pieces of data. So you found the numbers that split your data into equal size quarters. The 15th value, well, these are the cumulative frequencies at the side. So this is the 16th piece, so this will be the 15th piece at 125. Part B says find the interquartile range, and it even tells you how to calculate it, Q3 minus Q1. So we're going to do 125 minus 117, which gives us 8. Now we're looking for outliers, and specifically it says showing your working clearly, identify any outliers for these data. So we're going to follow these rules. An outlier is a value that is greater than Q3 plus 1.5 multiplied by Q3 minus Q1, which is the interquartile range. So Q3 is 125, and we need to add on 1.5 lots of 8. So that is going to be 137. Now, is there anything greater than that? If we look in the diagram here, we can see that 132, no, 139, yes. So we found our first outlier. There is 1 piece of data above 137, and that is 139. Now, following the second part of the instructions, it said take the lower quartile and subtract 1.5 times the interquartile range. So that's 117 minus 1.5 times 8, or minus 12. So that gives me 105. Now, is there any data below that? Well, 112 is definitely not, but 102 and 101, yes, they are both below. So we can say there are 2 pieces of data below 105. They are 101 and 102. And so it said identify any outliers. So we can conclude The outliers, therefore, are 101, 102 and 139. Because it's showing you're working clearly, I think we should be very careful to set that out nicely. Part D on the grid on page 21, or they have a backup one the page later, which is the one I'm working on. Draw a box and whisker plot to represent these data. Show any outliers clearly. So the outliers at 101, 102 and 139 can be illustrated with crosses. There's a gap of 10 and 10 boxes between these, so it's a nice scale with each one box representing 1. The box begins at Q1, 117, which I'm going to mark 4 boxes high, has a middle at Q2, or the median, of 122, and ends at Q3, the upper quartile, which is 125. So those numbers create the central box. And now the question is where the whiskers end. You've got 2 choices, both of which will be marked correct. You can either use the boundaries from your outlier calculations, which would be 137 at the top and 105 at the bottom, or the way I'm going to do it is you go back to the data and you think about the fact that you've marked 101 and 102 as outliers, so the next piece of data, which is 112, is your lowest piece that goes in the box plot. So I'm going to start my box plot at 112. So this was 4 boxes tall, this one's only going to be 2. I'm drawing my whisker. And for the top, I've put in 139 as an outlier, so the next highest after that is the biggest one that's part of my box, and that's 132, which goes here. Box stuff, so that's part D. Now next in the question we've been given some summarized data, sum of x and sum of x squared, and we have to calculate the mean and the standard deviation, so that's the square root of the variance for these data. So let's do part E now. The mean is going to be given by the sum of the data divided by how many pieces of data there are, and they've told us in the question, so we don't make a mistype, that the sum of x is 2299, and we know that the number of pieces of data is 19. Now if we put that in the calculator we get 121. Now for the variance, and then we'll find standard deviation in a second, you need to know how to calculate it. So I mean there is the long correct way to do it, which is taking each piece of data, subtracting it from the mean, squaring it, summing it up, dividing it by how many pieces of data there are. That would find you the variance, and then you could square root it to find n. But because we have these summation figures, it's better if you know by heart that the variance can also be calculated by doing the sum of your data squared divided by n and subtracting the mean squared. So they've told us in the question that sum of x squared is 2,79709. We can divide that by n, which is 19, and subtract the mean that we just worked out, 121 squared. And that will give us the variance. So let's work that bit out first of all. 2,79709 divided by 19 minus 121 squared, and that's giving 80.526 and so on. So then the standard deviation is equal to the square root of 80.526 blah blah blah. Square root answer, so I'm keeping everything nice and accurate, is 8.9736 and so on, and I'm going to give that as 8.97 to 3 significant figures. Okay, next up, for a random sample taken from a normal distribution, a rule for determining outliers is an outlier is more than 2.7 times the standard deviation above or below the mean. So this is a rule if a random sample is taken from a normal distribution. So then it says, find the limits to determine outliers using this rule. So I'm going to squeeze that down here, part F. So we would need 2.5 times the standard deviation above or below the mean. So for the lower limit, we would take the mean, which was 121, and subtract 2.7 times of this 8.9736. Let's put in the accurate one. So that's 121 minus 2.7 answer. And that gives a lower limit of 96.7711 or 96.8 to 3 significant figures. Of course, you shouldn't go into the line at the side, but I'm just trying to make it fit on the page so that you can see what I'm doing. So that's the lower. Then the upper limit is 121 plus 2.7 lots of the standard deviation. And that, now can I get back to this? Not quite, so we need to start from there. Next do this part. And next do the square root part. Okay, so there's our 8.9736 in the calculator. So we need 121 plus 2.7 lots of that. And that's giving me 145.2288 and so on. So that would be 145 to 3 significant figures. Now the last part of the question G says state, giving a reason based on some of the above calculations, whether or not a normal distribution is a suitable model for these data. So we need to think about what we've calculated and what we know about a normal distribution. There are a few different things that you could mention. One of the things is that a normal distribution is symmetrical, so we could consider whether this would be the case. And do we have any information to help with that? Well, in part A, we worked out that the median was 122, and in part E, we worked out the mean is 121. So they're close, but they're not exactly the same. If the mean is below the median, then it signals a negative skew, that there are a small amount of very low data that's pulling the mean lower than the median. And so you could argue that you shouldn't use the symmetrical normal distribution. Or another more recent thing that you've worked out is about these outliers. So according to this rule that we've worked out in part F, which says that this is a rule for determining outliers when you're dealing with a normal distribution, so your outliers would be lower than 96.8 or higher than 145. Now if we use that criteria and go back to here, then every single one of these pieces of data would not be an outlier, whereas our earlier calculations suggested that we should actually have 3 outliers. So we could say that, well, that doesn't match, that doesn't seem right for a normal distribution, the other work that we've done. And it's up to you which of those you would choose to write. So if I record the first one for you, we could say probably not suitable as the normal distribution is symmetrical whereas this data is skewed. And how do we know? Because the mean is lower than the median.